The second equation is dp on the left side, dp dr. That's to integrate, differentiate the pressure in respect of the r, the distance to the center of the system, is equal to 1 divided by r squared times log c squared. Log is the density of mass times c squared, the light speed square, plus p, the pressure. And then in a square bracket, times 4 pi g divided by c to the power 4, and times p r3, the pressure, times the distance to the center of the system, r cubed, plus gm bracket r, that is to say g, the Newton's constant, times the mass in respect of the function in respect of the r, divided by c square, and then another bracket, square bracket, 1 minus 2 gm r again, and then c square divided by c square r times r, and to the power of minus 1, and you say it is actually the inverse of this function. Now, the sixth procedure is now that we know that the P, the pressure, must be equal to a pressure function in respect of the mass density, which from the results of the above steps, including the results of the general relativity, some of which are not shown here for the sake of abridgment. We come to the conclusion that the P must be a P with respect of mass density log sigma, log, yes, log. And this is the form of the third and final equation of stellar structure. We come to the conclusion that it must be dp divided by d, not divided, the differentiate p with respect of r is equal to minus gmr. Whenever I say that m bracket r, that means we say mr, that means that m is a function of r, of the distance to the center of the system, times log r, log bracket r, that means the mass density which is a function of the r, the distance to the center of the system, divided by r square, the square of the distance to the center of the system. And this is actually just the Newtonian equation for hydrostatic equilibrium. This is just the so we have now gained the insight that the relativistic effects is only serving to deepen the pressure gradient relative to the Newtonian case. That is to say that the Newton equation is already correct, but it's not relativistic. Yes, it does not take account of the relativistic effect, and the relativistic effect is only to deepen the pressure gradient, which means that for an object to remain in hydrostatic equilibrium, the fluid of which it consists must experience stronger internal forces when general relativistic effects are present. So we come to the next step. The next step is the seventh step. By assume that loop is constant, and this is correspond to an ultra stiff equation of state of incompressible fluid. For example, the interior of a neutron star. This is the case. It's incompressible fluid, and it's ultra stiff equation of state. So by integrating the equation, the above equation, dp in respect of r is equal to minus cm r times loop r divided by r square. This equation, we get this mr is just equal when r is smaller than r or equal to big R. R is equal to 4 divided by 3 pi log R squared, R to R cubed. When it is R is bigger than R and R, and then 4 is equal to 4 divided by 3 pi log R cubed. R cubed is identically equal to M. What are M, what R, what are M and R? R is the radius of the star or the mass of the fluid under pressure. M is the mass parameter of the Schwarzschild metric describing the space-time outside the star or the mass. Now we come the center from the second equation of stellar structure. We have now derived the third and final equation of stellar structure, or the third and final equation of the Oppenheimer-Volkoff Equation, which is, as I read out first, the pressure, differential pressure, the respect of R is equal to minus 4 pi g, g is Newtonian constant, divided by 3 and c to the power 4, that's the light speed to the power 4, times r, which is the distance, the variable distance to the center of the mass of the system, times a bracket p c square plus p, the pressure, log is of course the mass density, and multiplied by another bracket, the pressure c square plus 3p, 3 times the pressure, the final bracket 1 minus 8 pi g divided by 3c squared to the power minus 1, that's to say the inverse of this function. And from this equation, after several substitutions and integration, which I've reached and skipped because it's too long otherwise, too complex, the derivation, we get the final equation p to the power, not p r, that is the pressure as a function of r, the distance to the center of system, is equal to log c square. Log c square, log is the mass density, c square is the light speed square, and bracket 1 minus 2 mu r square divided by r to the power 3, and then or the whole thing to the power 1 over 2. What the power 1 over 2 just simply means the square root of this thing. And what is the mu here? Mu is here gm divided by c square, which is a standard notation in general relativity. Mu just equal to gm, no Newton constant, times mass of the system divided by c square, light speed square, and minus 1 minus the bracket minus 2 mu. Mu I've just explained. This is equal to gm divided by c square. G Newton constant, mass of the system. M is mass of the system divided by c by r. Sorry, r. R is the is above the radius of the star, or the radius of the radius of the mass of the pressure of the fluid under pressure. The radius. Alright, now you have to see that from there's a denominator down there. It's just the same thing as the numerator, although it's just in reverse. On the numerator is 1 minus 2 mu r squared divided by r free all to the power 1 over half, minus that's 1 minus 2 mu over r to the power 1 half. But on the numerator, on the denominator, is just the reverse. This second bracket becomes the first bracket. The first bracket becomes the second bracket. That's the reverse order, in the reverse order. And so this is the third and final equation of the Oppenheimer-Volkoff equation. You can see that in this immediately you can see that because it's just the numerator and the numerator within the denominator are the same thing, and they're in reverse order. That means the whole thing can be cancelled simply to minus 1. That is the so now the equation is in the predicted form of P is equal to P bracket log. That is to say, the P now can be expressed as the pressure can be now expressed as a function of the net mass density stated in 6 above. So it's correct. We have obtained the correct derivation. And it's also we can immediately get P r is equal to minus log c square, because this is equal to minus 1 as a space. This is just cancel out, become minus 1. So it's equal to, and what is log square? Log square I have already given here. The mass as a function of r is equal to 4 over 3 pi log r free. And now we can sum to some first principle. The mass divided by the volume is equal to the log, that's the mass density. So the mass here is 4 over 3 times pi log r to the power 3, and the volume is just 4 over 3 pi radius cube. That is the physical volume. So it becomes out we can express the density as mass divided by volume. That's 4 over 3 pi log 3 to the power r to the power 3 divided by the volume 4 over 3 pi r to the power 3. So it's just the log. Cancel out the 4 over 3 pi radius cube. Become log. It is just the same as log here. So log c square, that's equal to log square. And so this just the mr square, just equal to the mass of the system, the whole mass of the system times c square. So this is the result of the Volkoff Equation, the Oppenheimer-Volkoff Equation. Perhaps we can use this as another demonstration and another proof that E is equal to mc squared. This is another. There are very many derivation methods of derivation of that energy is equal to mc squared. This is another one. I've stopped a bit here first.